Okay, this is the final video related to the anodizing case study. So we've basically taken a Six Sigma project all the way from the define phase through the measure phase, the analyze phase, and the improve phase. So in the improve phase, we have established a new process, a new way to run it, and we've established some new controls to get better performance and higher capability. The control phase, the last step in the process, requires that we put in place control plans, and there are notes I'd like you to read. In fact, let me back up. There are notes on control phase activities. They talk about things you do in the control phase. You also want to go back, if you so desire, and review the statistical process control sheets, sets of notes, and the reason for that is that in many cases an important part of the control phase is control charting some of the important inputs and outputs, and definitely control charting the KPI. Once you're in the control phase, the project is not over. You're going to monitor the KPIs and the process for some period of time. It depends on the organization, anywhere from a month to as much as 6 months, to make sure you've achieved the goals. At the end of this control period, where you've established the improvements have been made, you then turn the entire process over to whoever the stakeholders are for the particular process, and then it becomes their process to run from that point forward, and at that point the team is done. Or if you find that you have not met your goals, then the team may convene and decide to backtrack, or have a discussion with the project sponsor and see if it's worth putting more effort into it. Again, it often becomes a cost-benefit analysis. Is there benefit to continuing to try to improve the process? Okay. So basically, there are quite a few notes I've asked you to read. Improve phase activities, read about FMEA, and read about control phase activities, mistake proofing. These are all very straightforward topics that I'll leave to you to just read through the notes. The goal of reading through the notes is that you are familiar with the topics, and if you were to enter the improve and control phases of Six Sigma, you have the notes as a review, and you are aware of the different activities and topics that you need to be aware of, and methodologies you need to use. Okay. There we go. So finally, the bottom line is, remember way back when we started this case study, in the define phase, we decided that the key performance indicator would be yield, percent yield of parts per batch, charted over time on an individual's chart. Remember, we originally started with an as-is performance of about 19% yield, and we set a goal for the KPI of 90% yield. And at this point, again, it's important to use control charting on the KPI, and again, you should implement control charting on any key process input or output in a process. Again, that is part of the things you would do in the control phase, plus in the measure phase you most likely implemented some SPC on key inputs and outputs that you identified, and they may be a continuation of the same charts. So basically, I'm just going to go over to finish this and go to jump and discuss how things ended for the team. Okay. So eventually a new process was implemented, and we have a phase variable that gives us before and after, and we're interested in a control charting performance to see if we've made an improvement, and this is a perfect place to use a phase control chart. So we can either do a P chart based upon looking at the proportion of good parts, or I think it's just as easy to go ahead and use an individual's chart on the yield per batch. So I'm going to go to Analyze, Quality and Process, and let's use Control Chart Builder. Easy drag and drop visual interface. Okay. So lot sequence defines the sequence in which the lots were made. Okay. Yield is the CTQ, and we bring over our phase variable. Okay. So notice before the change we were running again around 19% yield with a lot of variation. After the change, okay, notice the major improvement. In fact, we've gone from 19% to about 99% yield. Okay. So we have more than exceeded our goals. Okay. So there's now a very consistent process with very little variation in high yields. That's because we've optimized the process, we found the root causes of variation in yield, and we found ways to control them. Plus we put in place additional controls on the inputs to the process to allow us to maintain high consistency. Okay. Now, some background information, and this is discussed if you read the Chapter 6 of the Visual Six Sigma book. What happened at the end of this? So let me give you some background. From this was a case study I was actually very much involved with personally. Once we had optimized the process and we determined how to run the process correctly, had identified where new controls were needed, we were challenged by some senior technical people. I mentioned them in the previous videos. They considered themselves experts on anodizing, and later I found out they had no idea what they were talking about. But they laughed at us. They said this design of experiment stuff is a waste of time, and those parameters you want to run at couldn't possibly work. And that's far away from where we currently run the process. So the general manager challenged them. If you don't want to use the solution the team has come up with, what's your solution? In other words, you think you have a better way of doing this. By the way, this problem had gone on for 2 years, and these individuals had done nothing to solve it. In fact, if anything, they made it worse. So he said, basically, neither of them had anything to say. He said, we're going with this solution. So we did 2 confirmation trials. The first trial, they ran at the settings that we recommended, and they had put at least some of the controls in place, not all of them. And they got something they had never had in the history of the process, 100% yield. Every single one of the parts was acceptable. Not only that, the quality inspector said these were easily the best anodized parts he'd ever seen from the process. Okay, so it looks like we've succeeded. Well, these same people came back and said, well, you just got lucky. Of course, how you just got lucky in going from 19% to 100% yield is a question. So we went ahead and ran a second confirmatory trial. These are actual production runs. Same thing, 100% yield, and the inspector said, if anything, these parts are even better than the last. Okay. At that point, they shipped the parts that had just been made to their customer, who said, these are the best anodized parts we've ever seen. In fact, you're really the only people who seem to have figured out how to do this correctly. Important point, before we started this project, their quality was so bad they were on the verge of losing this multi-million-dollar business contract. After we put in place our improvements, the customer saw the quality. They said, you're easily the best supplier. They actually gave them additional work. They gave them more work, and because the process now ran with very little loss, there was very high yield, the company was able to utilize the equipment to manufacture even more parts. So a process that had poor quality, had large backlogs, had a customer ready to walk out the door, thanks to a Six Sigma project, again all the way from define through control, now said, you're easily the best supplier we have for this product, and we're going to give you all the business, because no one else comes close to your quality. Not every Six Sigma project will end this way, but this is not unusual to see these types of dramatic improvements. So from the phase control chart, it pretty much tells the story. But if you look back through all of the notes, through all of the phases of the DMAIC process, it took a lot of work, a lot of determination, and a lot of rigor in using all of the statistical and quality tools to get us to the point where we had a better process. So the bottom line, this project was a great success, and even after it left the control phase, this process went on for several years to produce at a very high level. At that point, to be honest with you, I've lost contact with the company, so I don't know what happened in the future. I don't even know if they still make the product, but this was a major victory for Six Sigma and for this company, and really convinced people there is a lot of substance and value to continuous improvement strategies like Six Sigma.